All right, welcome back. This is our first section of Unit 4. Unit 4 is by far the longest unit in Pre-Calc 11, so you would like to build a good foundation of it, so then you can actually, finish the chapter smoothly. Okay, so Unit 4, 4.1, we are looking at the properties of quadratic function. There's a lot of definition here. Okay, so new words that we need to learn. So make sure you understand this lesson well. Okay. So first of all, what's a quadratic function? Well, quadratic you already know, right? Quadratic looks, whenever we see quadratic expression, in the previous unit, we've seen like ax squared plus bx plus c, and that's definitely quadratic. Now, function. Recall, function means if you have one single input, that gives you one single output. Okay, so one input gives you one output. There was a function notation that we learned in pre-calc or in math 10, and remember it was f of x equal to something, right? So quadratic function is in the form of f of x equals 8x squared plus bx plus c. Again, this means f of x means the name of the function is called f, and the input is x, and that's why we have ax squared plus bx plus c. Okay, so f of x, this does not mean f times x, okay, it's f of x. It's the function notation. Sometimes though you do see it written in the form y equals ax squared plus bx plus c. Okay, so for simplicity, right, recall f of x really is just the y value, and that's why we write y there. Okay, where a, b, c's are the elements of real numbers and a cannot equal to 0. Okay, this is the general form. This is the general form of the equation of a quadratic function. So y equals ax squared plus bx plus c, or f of x equals ax squared plus bx plus c is the general form. All right, now we have not seen what the graph of this function looks like. So I guess we will start with some table values. Okay. So we are going to do two different graphs. One is y equals x squared and one is y equals negative x squared. Okay, so this will be y equals x squared. I'll do that in red. I'll do negative x squared in blue. Okay, so since I'm still in blue pen, I'm going to fill all the table values for blue first. We're going to use negative 2, negative 1, 0, 1, and 2 as the x values. Okay. And now to find the y value, you simply plug this x in here. So we would have, I'll do the first one, y equals negative of negative 2 squared. So this is negative of negative 2 squared is 4, which is negative 4. Okay, so this is negative 4. You do the same thing with negative 1, 0, 1, and 2. You should get negative 1, 0, negative 1, and negative 4. Okay, so if you're not so sure, pause the video, try it yourself. Okay, so now I'm actually going to plot this on the grid. Okay, so let me make my x-axis and y-axis here. So x is negative 2, y is negative 4, that's my first point. Negative 2, 1, 2, 3, 4, here's my first point. Negative 1 comma negative 1 is right here. We have 0, 0 as the point, so that's the origin, 0, 0. We have 1 comma negative 1 right here, and 2, negative 4. So that's what the graph looks like. It looks something like this. It's not going to be a straight line like the graph we've seen for linear functions. Okay, so this is a curve. It looks something like this. Okay, it's a curve. It's almost like a U shape. Yeah, almost look like a U shape. Okay, for the that's the negative x squared graph. Now for the positive x squared, I'm going to use the same x values. So negative 2, negative 1, 0, 1, and 2. So I'll do again the first one, y equals x squared. So just negative 2 squared. This is simply just 4. So that's 4. Again, if you want to plot in these numbers yourself, you definitely can do that. And once you've done that, you should get 4, 1, 0, 1, and 4. So you can see they're almost the same, but just negative. Or the blues are just the negative of the red ones, right? So if we plot the point, negative 2 and 4 is right here. Negative 1 and 1 is right here. 0, 0 is here. 1 and 1 is here. 2 and 4 is right here. So the graph looks like this. So they are really identical graphs, except they are flipped, okay, upside down. Okay, they are so what we called is they are congruent, right? Because they really have the same shape, but just flipped. Okay, they are congruent, but then just flipped. They have the same size, right? That's basically what it is. Okay. Okay, so those are, I mean, this is the quadratic function. Okay, this is the graph of a quadratic function. It's an U shape. Okay, and there's a name for this particular shape. It is called the parabola. Okay, this is a parabola. It is the graph of every quadratic function. It's the shape, right? It's the shape of the graph of every quadratic function. This is called a parabola. Okay, we are going to look at some properties. Okay, that's what this lesson is about. So we have some definitions here. There's the vertex. Vertex is either the highest or the lowest point of a parabola. Okay, they are either the the maximum. So it's a maximum if it's the highest. Okay, actually, I'm going to do in different colors. Or the minimum point if it's the lowest. Okay, so in our example here, you can see the red graph y equal to x squared has a minimum. So this one is the lowest. It has a minimum, and the vertex is actually 0, 0, because that's the lowest point, right? This point is the lowest, and we call that the minimum, and that is the vertex of that parabola, and it is at 0, 0. For the maximum, we do have a maximum for the blue graph, right? This point right here is the highest. So this is the highest, and the coordinate of that maximum point or vertex of the blue graph is, well, same thing, 0, 0. Okay, oh, I guess I just answered the question right here. The vertices for y equal to x squared and y equals to negative x squared, they are actually the same point. Okay, but I mean, ultimately they are two different functions. So you have a vertex for the blue graph, which is at 0, 0. You have a vertex for the red graph, which is also at 0, 0. One of them for the blue is the maximum. The vertex for the red is the minimum. Okay, so that's the vertex. Axis of symmetry. Notice how these two graphs, they are actually symmetrical. Okay, so if you just look at the red graph alone, okay, if you kind of just cover the bottom half, if you just look at the red, it's actually symmetrical, right? It's a mirror image. It's a mirror image, okay? So if you put a mirror right on the y-axis, you can see on the right and on the left, they are identical, okay? Let me say it again. If you put a mirror right on the y-axis, what's on the right and what's on the left, they are exactly the same, okay? So this line, the y-axis right here, is what we call the axis of symmetry. It's not always going to be the y-axis though. Okay, the graph could actually move around, therefore your axis of symmetry would shift. However, in these two examples, our axis of symmetry is the y-axis. It really is the vertical line that cuts the graph in half. Okay, so it says it intersects the parabola at the vertex, so that's important. It intersects the parabola at the vertex, and it's a vertical line. The parabola is symmetrical about this line. Okay, what are the equations of the axis of symmetry for y equals to x squared? Okay, so for that one, I'm going to do it in red. And for this one, I'm going to do it in blue, because that's the blue graph. Well, the equation is the it's the y-axis. And I don't know if you remember, the equation for the y-axis is y equals to 0. Okay, and for the y equals to x squared graph, the equation of the axis of symmetry, well, it's the same line, right? It's the vertical axis, it's the y-axis, so it's the same equation. Okay, all right, domain. I don't know if you remember about domain, but domain is the all possible x values. So all the values that we can actually plug into the function is the domain, okay? So what is the domain for y equals to x squared and y equals to negative x squared respectively? Well, if you think about this graph, let's look at the red graph, okay? The red graph is going to keep going up, and it's going to keep going up. And it's also keep going to the left. It's also keep going to the right. So really, it's just going to keep going to the left and right. So we can actually have any x values, okay? All x values are actually possible. So the domain for the y equal to x graph, y equals to x squared graph, in this case, domain is all real numbers, because x could be anything. For the y equals negative x squared graph, same thing. It's going to keep going to the left and downwards. It's going to keep going to the right and downwards. So because it's keep going to the left and right, therefore the domain here is also going to be all real numbers. Okay? Range is we're looking at the all possible y values. So for the y equals negative x squared, well, it's going to keep going downwards. So it can be as negative as possible. However, because we do have a highest point right here at 0, 0, it does not go anywhere higher than that point, right? It doesn't go higher than that point. Therefore, we do have a maximum. So our range is going to be y can only be less than equal to 0, right? It cannot be anything more than 0, right? Because we have the highest y value of 0 right there at the origin. So similarly, for the red graph, y equals x squared, you can see the graph keeps going up to the left, keeps going up to the right. It does not go down. Okay, so we have a minimum right here at 0 for the y value, and therefore that is the range. Y has to be greater than or equal to 0 because we have a minimum at 0, but we don't have a maximum because it just keeps going up. Okay, so that's the range. Hopefully, these terms make sense to you. Okay, let me just go over them once again. Parabola is simply just the shape of the graph. Okay, it's called a parabola. Vertex is either the maximum or the minimum of the parabola. Okay. Point, maximum or minimum point. Axis of symmetry is the vertical line that cuts the parabola in half. Okay. Domain is the all possible x values. Range would be the all possible y values. Okay. So here is two questions that we can fill in the blank, I guess. It says, I mean, we can notice from the two examples that we've done. It says when the coefficient of x squared is positive, the parabola opens. Okay, so this is the case where the coefficient of x squared is positive. You can see that's the red graph. The parabola opens upwards, right? So the parabola opens up, and if it opens up, the vertex would be a minimum. Okay, it is a minimum. Whereas for the blue graph, when the coefficient is negative, right, when the coefficient of x squared is negative, the parabola opens downwards. It opens down, and if it opens down, it looks like this, right? Therefore, we have a maximum. So the vertex is a maximum. Okay, hopefully that makes sense to you. Okay, you can see if the coefficient of x squared is positive, the graph looks like this. It's a parabola opening up, right? Therefore, we have a minimum right there. Okay, that's our vertex. All right, so those are definitions and some observations that we can see from those two examples. Now we're going to try to graph something that's a little bit more complicated. Okay, so I'll show you this one here because, I mean, well, you know what, I will ask you to fill in the blanks. Let's just go with -4, -3, -2, -1, 0, 1, 2, 3, and 4. So go ahead, try to plug in. I'll do the first one and I'll let you do the rest. Okay, so first one, I'm going to plug in -4 into x squared. I don't even know if I have room to plot on the grid. Whatever, that's okay. So -4 squared is 16. 16 times 2 is 32. 4 times -4 is -16. Minus 6. So that's 32 minus 16, which is 16. Minus 6 is 10. Okay, so this is 10. Okay, so you can do the same thing and fill in the rest of the table. Okay, so this is what you should get. Okay, these are the values that you should get once you plug in these x values into the quadratic function right here. I noticed that these two values are a little bit too big for our grid, so I'm not going to worry about that. I will just plot the rest of the points. Okay, so -4, 10, so that's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right here. Negative 3, 0. 1, 2, 3, 0 right here. Negative 2 and negative 6. 1, 2, 3, 4, 5, 6. Negative 1 and negative 8. 0, negative 6 is right here. 2, comma 10 is, 1 and 0. And 2, comma 10. Okay, so now here is my parabola. It's very skinny. Looks like this. Looks more like a V than an U. Okay. It should be a curve though, okay? I know I can't really demonstrate that it's a curve because it's kind of tight. Okay, that's okay. So that's our graph. But again, you can see it has a feel of a U shape right here, right? All right, part A, X-intercept and Y-intercepts. We can actually look from our graph or from the table. The X-intercepts are negative. Remember, X-intercept means when Y is 0. So that's right here and right here, right? So negative 3, comma 0 and 1, comma 0. The Y-intercept happens when X is 0. That's right here. So this is Y 0, comma negative 6. That's the Y-intercept. Okay. Part B, the coordinate of the vertex. I think it's quite clear. We have a vertex right here. That's the lowest point. And how do I know that's the lowest? How do I know it does not? Like, for example, how do I know it doesn't go like that? Okay. What you need to remember is that it is a symmetrical graph, right? Parabola is symmetrical. So if you have two of the same y points right here, okay, two of the same y values right here, that means the value or the point that's right in between those two, right? You can see that's 0 and that's negative 2 for the x values, right? 0 for the x, 0 for negative 2 for x here. So right in the middle between those two x values, which is negative 1, that's where the vertex is going to be because it's symmetrical. Okay, so this has to be the vertex. So the vertex is negative 1, comma negative 10, I think, is it? Negative 8, sorry. Okay, negative 1, comma negative 8. See the equation of the axis of symmetry. So remember, axis of symmetry is simply the vertical line that cuts the graph in half. So this right here, this line is the axis of symmetry, right? It cuts this parabola in half. And recall, it always goes through the vertex. So the equation of the axis of symmetry is simply x equals negative 1. Okay, it's always the x coordinate of the vertex. Okay. Finally, part D, we're looking for the domain and range. Now, domain, if we look at this graph, this tells me that the graph is keep going to the left and up. This graph is keep going to the right and up. So it's going to keep going to the left and right. Therefore, the domain is all real numbers. Okay. This is the domain. As for the range, again, from these two arrows, it's telling me that it's going to keep going up to the left. It's going to keep going up to the right. So it's only going to go up. It's not going to come down anymore. So we do have a minimum because this graph opens upwards, right? So this is the minimum. Therefore, the y values, all the y values have to be greater than or equal to that particular y value, which is negative 8. Okay, so that is our range. And that's it. Okay, so last line here says the x-intercepts of the graph are also called the zeros of the function. I think we talked about this the other day. Zeros of the function, roots of the equation, or the x-intercepts, really they all refer to the same thing. Okay, they are all kind of the same thing. Okay, so that's the practice question. Hopefully, well, I kind of show you everything there, but that's okay. This is something new. Okay, we have never seen a parabola before, right? It's all in lines, linear functions. This is new. Okay, so I don't mind showing you everything here. All right, last example here, it says, and again I will show you this. It says a projectile is launched upward. Its height, h meters after t seconds, is modeled by the equation h equals negative 2t squared plus 8t plus 5. Okay, part A says graph the quadratic function. So now we will need to come up with the table of values first. We will learn how to graph these without table of values later on, but for now we will just use table of values. So part A will use table of values. Okay, so I will ask you to think about what x values we should use here. Okay, so think about it. All right, I don't know which x value you picked here. I'm just gonna use, I don't know, actually I don't really know either. I'm just gonna use -3, -2, -1, 0, 1, 2, and 3, and then just want to see how, what we get. And I'm gonna try, I'm not gonna commit that much yet. Okay, I'm gonna try -3 first. Okay, so if I plug in -3, you should get -3 squared is 9, -18, okay, I'm definitely not going to use -3. Okay, -3, I'm going to get a very, very negative number. Okay, so I am going to actually skip -2 as well. I'm just going to try -1. Okay, -1 squared is +1. And then times -2 is -2, plus 8 times negative. Okay, so I'm going to show you -2. -1 squared plus 8 times -1 plus 5. I believe this is -5. Okay, that's not too bad. Okay, that's acceptable. I'll keep that one. Okay, and then I'm going to keep going with a 0. That is just going to be a 5. Okay, because you plug in 0 into t, that's a 0. That's a 0, so just 5. When I plug in 1 into x, let's see what I'm going to get. That's what is it, 13, 11. I'll plug in 2, that's -8. -8 plus 16 is 8, 8 plus 5 is 13. I'll plug in 3, and okay, so basically what I'm looking for is, I'm looking for 2 of the same y values, because once I found that, then I can know where the vertex is. Okay, so that's why I'm looking for 2 of the same y values. Okay, so you plug in 3. Okay, this is getting too big. I'm gonna write it down. 8 times 3 plus 5. This is -18 plus 24 plus 5. This is 11. Oh, perfect. There's my vertex right here. Which means I know if I plug in 4, it's gonna be 5. Okay, because again, it's symmetrical, right? This would be the vertex. And you can see that's 11, 11, 5, 5. So if I put a 5 here, it's going to be -5. Okay, so now I'm going to plot the graph. Okay, I'm going to graph this function right here. So -1 and 1, 2, 3, 4, 5 right here. 0, 5, 1, 2, 3, 4, 5. So here's my x-axis, right? That dot tells me that's the origin. X-axis, y-axis. 1, 11. Oh man, I don't have enough room. Okay, I'm just gonna make one. Let me just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay, that's not quite enough. And 3, that's 1. Oh no, 2, 13. 2, so that's 11, 12, 13, somewhere here. And then 3, 11 goes back down. 4, 5 goes back down. 5, -5 goes way back down over here. Okay, so here is the parabola. Okay, so this is the function. Okay, so that's part A. Part B, I'll do in blue just to differentiate. A lot of calculations over there. Okay, part B, identify and explain the significance of the intercepts. Okay, so we actually have the y-intercept right here. Y-intercept is 0, 5. Okay, that's right there. We have 2 x-intercepts. However, they are not nice numbers. Okay, so what do we do? Okay, so remember, we can actually solve for x-intercept by making y equal to 0. So I'll do it right here. So when you make y 0, that means the height is 0 in this case, and that equals to -2t squared plus 8t plus 5. Okay, so again, let me say that again. If you're looking for y-intercept, that means you plug t as a 0, and then you get the y value. That's the y-intercept. To find the x-intercept, what you need to do is you make the h 0 in this case. So I guess I shouldn't really say y-intercept. I should say h-intercept and t-intercept. Okay, this is my h axis, and that's my t-axis. Okay, so if I want to find t-intercept, that's right here, I need to make h 0. Now this is a quadratic equation that we know how to solve. Okay, so I don't think this is factorable, so you could either complete the square or use quadratic formula to solve. I'll use the quadratic formula, so I'll show you, quickly recall. The quadratic formula is x equals, but here the variable is t, so I'm going to say t equals negative b plus minus b squared minus 4ac divided by 2a. Okay, I'll let you do it. Okay. Alright, so here if you use the quadratic formula, this is what you should get. T is either equal to 4.55 seconds or negative 0.55 seconds, which makes sense, right? You can see we have two x-intercepts, one here and one there. Okay, so now the t-intercepts are negative 4.55 and 0. The other one is negative 0.55, 0. Now, what are the significance of these intercepts? Okay, so first of all, the y-intercept, 0, 5. What does that mean? Well, this is the t-coordinate, which is time, okay? So this is telling me when time is 0, so that means before the projectile is launched, the height of this particular projectile is 5 meters above ground. Or above whatever, right? Above water, above, I don't know, above the height of 0. So I'm assuming it's ground, okay? So at time equal to 0, so before you launch the projectile, this projectile is 5 meters above the ground. Okay, so that's what that means. For the t-intercept, this is the time and this is the height. When the height is 0, that means it takes projectile 4.55 seconds to land on the ground after you throw it, or after you launched it, right? At 4.55 seconds after the projectile is being launched, it will land on the ground, okay? It will land on the ground 4.55 seconds later. This negative 0.55 makes absolutely no sense, okay? Because the time cannot be negative. It is just the modeling, right? That is just the shape of the graph, that's all. But really, so in reality, the graph, this particular graph only is important right here. This portion does not matter. Okay, let me redraw it, okay? Really, the only part that is important is this. Right? From here to here. You throw it up and it lands right here on the ground. That is basically the path of this projectile. Okay? So the negative time makes no sense in the reality, and the negative height again makes no sense in reality. Okay? So really, that's only part of the graph that we're interested in. Okay, so that's the significance of the intercepts. Okay, next, the coordinates of the vertex. The vertex we found it was 2, 13. Okay, because again, this is right in the middle between these two of the same y values. So I know for sure that has to be the vertex. Okay, domain and range. So now this again, domain and range. We don't really care about this portion, nor these portions, okay? So the domain in this particular situation only goes from 0 to when it lands, which is 4.55 seconds, okay? So this is the only portion of the graph that we actually care about. Okay, we don't care about when time is negative because that makes no sense. This portion doesn't make sense because the projectile, we're assuming the projectile is not super heavy, so it, kind of cracks the ground or something, cracks the cement, whatever, right? So it just lands on the ground. So that's the time from 0 to 4.55 seconds. That's the entire path, right? That's the entire duration of this projectile. So that's the domain. For the range, same thing. We don't care about negative time, so this portion doesn't matter, and we don't care if the height of this projectile is negative, because it can't be, okay? So the range in this case really goes from 0, that's when it lands on the ground, all the way to its highest point, which is the maximum, so that's 13 meters above ground. Actually, does it say meters? because it does say meters, okay? So that would be the domain and that would be the range. So when we think about domain range in the word problem, we need to think about its context, okay? Sure, if this is just a graph, then that would be the domain range. You don't need to think about the context because there's none. But there is context in word problems. So in that case, your domain range needs to be changed, okay? You need to think about which part of the graph do I actually care about, right? It actually means something in real life, okay? And that's the only part that we will consider. Okay, so this is the lesson for 4.1. It's just the properties of quadratic functions. It's something new, completely new. So you have never seen the graph of parabola before, right? So this is new. So make sure you understand, do practice questions, ask for help, and good luck.